All right, so this is our lesson on inscribed angles and polygons. So basically we're going to start out with this inscribed angles circles theorem. So this is kind of a special case. So we learned in the last chapter that an inscribed angle is 1/2 that intercepted arc. So if I know this arc, I can take 1/2 and find this angle, okay? But if I know already, right, that these two angles are intercepted at the same arc, which is AB, right? Angle C is intercepted at AB, and angle D is intercepted at AB. This arc is going to be the same, which means that these two angles are also going to be the same. So that's what this inscribed angles of a circle theorem means. So you might be given a problem that looks like this, okay? And it's not really asking you anything right now, but it would, let's just say it's asking, okay, find angle F, okay? I know since angle E is intercepted by the arc GH, and angle F is also intercepted by the arc GH, then I can conclude that this angle F is also 75 degrees. So that's all it's saying. That's what that theorem's saying. All right, so let's go down and let's kind of review some problems. So if we know this arc right here is 90 degrees, we know since this is an inscribed angle that this angle right here is just 1/2 the measurement of this arc. So 1/2 of 90 is 45. Okay? Then same thing over here, right? But this time, if we're given the angle, how do I find this arc? Oh, okay, I'm gonna double 38 to find the measure of TU. Okay, so that's 76. All right, and then over here, we're going to use our theorem that we just talked about where, okay, if I know this part right here is intercepted by the arc ZW, then I know this red angle right here is also intercepted, well, since it's also intercepted by the same arc, I can also conclude that this is 72 degrees. Kind of need to fix my arrow. Okay, yeah. So that right there is 72 degrees. Okay, so pretty straightforward. All right, so let's move down to these other theorems we got going on. All right, so the first one is the inscribed right triangle theorem. Okay, so this basically is just telling me if a right triangle is inscribed in a circle, then the hypotenuse of is the diameter. Okay, conversely, if one side of an inscribed triangle is the diameter of the circle, then the triangle is a right triangle. So, okay, so this is like a lot of words. Just to basically say, okay, we know that this is our diameter. The diameter is a straight line through our circle. So that means it cuts our circle in half. So if the whole circle all the way around is 360 degrees, I know half this circle is going to be 180. You with me? Okay, since I know this arc right here is 180 degrees, this inscribed angle B has to be 90 degrees. Okay, so that's where it's coming from. We're kind of, in a way, proving this theorem by saying, okay, half the circle is 180, so that means that this line, the angle that's intercepted at the arc at 180 has to be 90 degrees. So if there's a diameter that involves a triangle, then one of the angles, the angle across from the diameter, actually, more specifically, is going to be 90 degrees. Okay? Then the other one we're going to be talking about is inscribed quadrilateral theorem. So a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So, sorry, I had a yawn come on. It's not because this is boring. This is awesome. Okay, so basically, it's just I'm tired and I'm pregnant. But here we go. Let's get back to the problem. Inscribed quadrilateral theorem. So basically it's saying if there's a quadrilateral in here, guess what? DF are equal to 180 and EG are equal to 180. So it's kind of like that when we're talking about the parallelograms and like we were back with parallelograms and all those different quadrilaterals. It's like kind of a similar theorem, except our theorem was that these were equal. Now just remember that these are always supplementary. Okay? All right, so let's go down here. We're dealing with circles. Okay, so let's go down here. Try to lighten up the screen a little bit if I can. Nope. Okay. All right, so here are some examples. So let's look at this first one. Okay, we know this is the diameter. So what do we know about this angle? It's a right angle. So I know 2x has got to be equal to 90 degrees. So x is equal to 45. Okay, and then based on my quadrilateral rule, it said the angles opposite of each other in the quadrilateral are equal to 180. So I can do z plus 80 is equal to 180. I'm going to subtract 80 on either side. Z is equal to 100 degrees, or just 100. And then same thing here. We have y plus 120. You see that? Yeah. Is equal to 180. Subtract 120. And so y is equal to 60. And that's it. All right, so let's go to some more example problems. So the ones at the bottom of this paper are going to be most similar to your homework, so make sure you either fast forward till the end if you feel like you got it, or wait till we get to the end. Okay, just keep watching. All right, so measure angle A. Again, this is an inscribed angle, so I'm just going to take 1/2 of 84. 1/2 of 84 is 42. So angle A is 42 degrees. Okay, this one's a little trickier. We have to use more of like a two-step problem. Okay, we got to use our knowledge of this, that this is always 360 degrees. So to find how much DF would be, right, because we're trying to figure out what angle G would be. Okay, so we need to know what this arc is. We would do 360 minus 70 minus 120. Okay, and that will give us the measurement of the arc. So again, the 360 I'm getting is from, we know all the way around a circle is 360 degrees. So 360 minus 1, I'm just going to say 190. Yeah. Okay, so this is 170. Okay, so if this arc is 170, I can find this angle by dividing 170 in half. Okay, and so I'll get 85. So G is equal to 85 degrees. All right, let's keep going. All right, so this one, you have to notice something, okay? You have to notice that this line right here is our diameter, which means it cuts my circle in half. So I know that this arc on this side will be 180 degrees. Okay, and if I know 160 is 180, how can I find this arc? Same way we did this last problem. We can do 360 minus 180 minus 160. And you can do some kind of like quick math too, right? 360 minus 180 is 180. 180 minus 160 is 20. So right here, right, this is 20 degrees. So to find the measurement of little angle N, we know we take half of 20. So the measure of angle N is 10 degrees. All right, then over here for the measurement of arc, this time we're looking for the measurement of arc. This one's pretty easy. Right, we just do the opposite of what we have been doing. We're going to double 67. So 67 times 2 is 134. All right, let's go over to these. So at the very top up here, it's the similar idea of what we just did with 6. We know this is angle 30, or U is 30 degrees, so we can find VT by doubling, okay, doubling 30, which is 60. However, you have to read the question carefully. Did we find arc VU? No, we did not. Okay, so notice VU is all the way over here on this side. Okay, or it's all the way, actually, no, VU is all the way on this side. Okay, the reason we know they're talking about this VU and not the big arc is because they would refer to this one as VTU. Okay, so it's just something to keep in mind. Okay, so we're going to find this arc right here. So we know because this, again, is our diameter, this is going to be 180. And so how we have found these arcs in the past is doing 360 minus 180 minus 60. Okay, so again, I believe it's just 120. Yeah, 120. So we know VU is 120 degrees. Okay, so let's move on to this one. We're going to find the measurement of WX. And notice again, WX wouldn't be this way, right? Because we would have to include the Y. So we're just talking about this arc right here. So we know this is 110. We can find this big arc right here by doubling 75. So 75 times 2 is 150. 150 plus 110. And we're going to subtract that from 360. Just like we did. So I don't know why I wrote an equal sign. 360 minus 150 minus 110 will give me this arc right here. So 360 okay, and that gives me 100 degrees. So we know WX is 100 degrees. Okay, which makes sense, right? Because this is 110. Okay, so this one's just a little shorter than 110, so 100 degrees makes sense. Okay, these over here is saying name two pairs of congruent angles. So there's more than one answer for these problems. So I'm going to name, oh, it says name two pairs. So, okay, never mind. This is all the answers. So angle B and angle A, they're sharing arc CD. So angle A and angle B. And then another pair would be D and C, and they're both sharing arc AB. So angle D and angle C. All right, if you want to pause the video and try this next one, you can. All right, here we go. So same thing. We know angle X and angle Y share this arc right here. So angle X and angle Y is one pair, and then our other pair shares the arc XY. So angle W and angle Z. Oops. These two are congruent. Okay. All right, so these are problems that are going to be similar to your homework. Let's see if I can get it focused again. Yay, okay. So your homework's going to be similar to these. You need to notice a couple of things. First of all, we've been talking about inscribed angles, so I don't want you to get confused. If it's a center angle or an angle at the center, okay, remember these are congruent, so this is 46. So I don't want you to try to double that, okay, because it would only be half if it was like touching the outside of the circle. Okay, so we know this is 46, or this is 46 is 65. How can I find this part right here? All right, so this right here is a diameter. So if it's the diameter, I know this whole thing is 180 degrees. So I can do 180 minus 46 minus 65. And that'll get me my calculator is not working. Okay, so that's 69. So we know this part's 69, but it's asking for L MK. So it's asking for this angle right here. Okay, so if I know this is 69 and this is 46, what I can do is I can add these two and it'll give me this whole arc. Okay, and we know that these two sides are vertical angles, right? So I can add these two and it'll give me what this angle is going to be. So 69 plus 46, which is 115. And again, central angles, okay, central angles are the same thing as the arc. So if I'm looking at this arc, 69 here, this angle right here is also 69. So just want to make sure you remember that from last time. All right, so let's move on to this question. So this question right here, again, we're going to use our knowledge of 180. It's not giving you a description on what to do, but I want you to solve for x. Okay, so we're going to solve for x. Now, there is a harder way to do this, and there's an easier way. The harder way, or the longer way, is to take this. Okay, I know this is x plus 74. These are vertical angles, so, okay, this has got to be x plus 74. Then you can subtract from 180 and find this one. But there's also an easier thing using that same knowledge I just talked about. You see how we know this is the diameter? Okay? So if this is the diameter, I know this whole arc is equal to 180 degrees. So I can just do 111 plus x plus 74 equals 180. And then I can solve for x that way. All right, so from there, I'll combine my like terms. So this is 185 plus x equals 180 minus 185. X is equal to -5. And it's okay to have a negative number because if I plug this x back in, right, -5 plus 74, that's going to give me a positive arc there. So don't worry so much about getting negative answers. It's okay. That is okay. All right. Here's another example problem. Okay, so this one's a little easier, right? We have an inscribed angle. We know this arc is 100. Just don't get confused by this like line here. I would just kind of ignore this line, and I would see, oh, okay, this is 100 degrees, so this has got to be half of 100, so 50. That's it. All right. Same thing with this one. Right, I know this is the angle I'm looking at. So I'm going to ignore these other lines here. And I'm just going to look at, okay, I know the arc. The arc is 62. So I know this angle right here has got to be 31. All right, so this one I was thinking, okay, well, we could use our theorem, right? But we aren't really given many angles inside here. So what I would do is I would use the outside to do this problem. So if you want to, again, if you want to at any time pause it and try it on your own and see how far you get and then check it, that's fine too, but I just want to go over questions like this. So I know this is 81, so I know this arc over here is going to be 81 times 2, which is 162. Okay, so if I know this is 120, this is 162, and this is 52, can I find this arc right here? Yeah, right? I can just do 360 minus 162 minus 120 minus 52, and then I can find what this arc would be. So let's go ahead and do that. There's probably a faster way to do this, so if you find a faster way, go for it if you get the same answer. I just felt like this is the most simple way to do it. Okay, so right here, this is 26 degrees. So right here is 26. So I know, right, this angle right here is intercepted by this whole arc, PDE, okay? So I can find this whole arc by doing 26 plus 52. So let's do that real quick. Okay, so I know this whole arc is 78 degrees. So if I know this whole arc is 78, I can take half of it to find this angle. So I'm going to divide that by 2, and I get 39. Okay, so that's my answer. All right, here is the last one. All right, so the last one, so this time we know, okay, this is 57, okay, so I can find this arc right here, okay, by doubling 57, so 57 times 2 is 114, okay, and then I know this right here is 180, so I can do 180 minus 114, and I can get that this arc right here is 66. So again, this is 180. So I just subtracted 180 minus 114 and got 66. Now I can see, okay, this angle is intercepted by 66. So take half of 66, this is 33. So that's it. All right, hopefully this helps. Please let me know if you have any questions, and hopefully I'll see y'all soon. Bye.